Okay, so if you would have asked me around 1 week ago what this presentation will be about, probably it would have been about something else. Okay? This presentation is about a trend that happens at this moment that started and starting rolling like a snowball within the communications community, which is actually the rise of private networks. It's becoming more and more prevalent. I mean, you will ask me now, do you know about Wi-Fi? Everybody has a Wi-Fi access network. Everybody has a private network. It's not about that private networks. It's not about the enterprise private networks with Wi-Fi. It's about how 5G will impact these private networks and how all these private networks will be redesigned because of the qualities of the 5G technology. Good. So let's start with what is 5G. 5G is meant to be, again, a middleware level between a lot of applications and a lot of radio technologies to provide connectivity. Wireless connectivity, but also wired connectivity at this moment. And there are discussions actually to look also towards the satellites, towards whatever access, whatever technology that can send a bit. If you can send a bit, it should be named 5G. Reason for this is that 4G was actually a very big competition between Europe and United States. Do you remember WiMAX? WiMAX one day was supposed to be the greatest 4G technology. Ultimately, it was LTE. And for any new technology to develop in a sane manner, it has to optimize whatever was done before, and at the same time to go against new markets. And now that LTE is actually a global network, the second one after GSM, there should be something else that would be interesting. And this something else is actually this direction of private networks, which, of course, being passed through the filter of the big vendors, through the carrier-grade vendors, and through the operators looks anything else but a Wi-Fi access network. Now, good. So what are the key communication changes within 5G? First of all, everything becomes software. Now, this already happened, more or less. Also, vendors and operators discovered that software programs that run on Linux can run on Linux. And they discovered that Linux can run on a lot of servers, and suddenly they made 1 + 1, and they discovered that all the network components can be software. Not to forget the increase of capacity of the compute units and of memory and so on that actually triggered this. Second one is that operators are looking more and more to move the intelligence towards the edge. With 2G, because the technology was probably 20 years ahead of its time, boxes were split in the network between the base station and the core network to be able to respond to the time constraints of the communication. Now with 5G, this happens in reverse order. We want to have 1 millisecond round-trip time delay, we move things to the edge. But there is also a third part, integration of the local access networks. Because all operators and all vendors are looking how successful these private networks are, and they understand the need that actually this is the place where communication was not covered by the carrier-grade networks. And these networks are mainly Wi-Fi at this moment. Some very, very advertisement level advantages of the 5G technologies is we can do dedicated networks. We can put the network functions at different locations. There is finally a sort of flexibility within the network. And that local access networks can use carrier-grade network technologies. Now, from the software network function perspective, it's like an ocean. We never know what type of servers the other department bought for the installation of the software. You visit the customer, you want to install something, and you discover that they have a Pentium 2 in a corner, and this is the only computer that they can give to you for the proof of concept, because everything else is already used. It's this ocean. Sharks are appearing everywhere. Or that they don't have Ethernet cables longer than 2 meters while the distance between computers is 5, and things like this. There is a second perspective which was brought by this NFV trend, which is an infrastructure perspective. Now that we put software on top of common hardware, we need to manage it in some way. And telecom networks are managed networks. And from this perspective, there is a super big management layer that should sit on top of everything, do device management, do connectivity management, do network management through software-defined networks, controllers and switches, and also be able to deploy as containers, virtual machines, and so on, everything. And this should come under a very big umbrella, because we love that our networks are managed from a single point. Good. And then a little bit longer as a perspective. Now there is a cross layer. As we have invented a new layer into the network stack, a new cross layer appeared into the stack. Now, probably you're not familiar with, and you don't want to be, 3GPP standardized a new system architecture, starting from the 4G one and starting slowly to modify it to address the 5G requirements. What is new is the control plane, user plane separation, adding slice selection functionality, integration finally of the policy function, and a separation between access mobility and session mobility function. Otherwise, everything is software. It will act as an upgrade of the old components. They are just grouped, regrouped, and reshuffled a bit to address a higher number of devices, to address higher capacity, and specifically to address non-IP type of communication. Because people that own factories are not so interested in changing their non-IP communication with an IP one. So why not give them a big circuit between the device, base station, gateway, through which non-IP data can circulate. What is also interesting is that finally 3GPP realized that it works as software upgrades. So the interconnection between a 4G system and the 5G system will not be through interconnection gateways anymore. It will be through upgrades of software components. The MME, where is it? The PCRF will sit into the PCF. The UPF will be combined with the PDN gateway U, and so on. Practically, the two components will sit within the same software and have two interfaces. Because why not? We can send two protocols through the boxes. Another interesting part is that in order to realize a better integration with these private networks, non-3GPP accesses will allow, like Wi-Fi networks, will allow authentication and authorization through 3GPP accesses. For example, getting into an airport, the authentication and authorization for the Wi-Fi in the airport will be done through the 3GPP access. So the 5G will do all the offloading and the integration of things. Another interesting part is that telecoms actually forgot one internet protocol to be brought to the carrier-grade architecture. And no, this is not SIP. SIP is IMS. This is HTTP. The full control plane of 5G will be based on HTTP2. How this will work, what will happen with the interconnection to diameter nodes, this is still to be discussed. The standard that will get its first release in December this year has as mandatory HTTP2, because somebody saw an architecture with microservices and said, this is what I would like to have. A very nice mega bus on which to connect a lot of little boxes, and then through this to have my new internet-like architecture. This might be the end of the telecom networks as we know them. This might be a new beginning. It happens exactly the same as it happened with the all IP architecture. Let's see what IETF brings up, and let's bring it also into the 5G architecture. Now, of course, the classic architecture will remain there. Vendors have their own patents to protect and their own interests into that, but the new one will be there, HTTP2 with JSON. How it will work, if it will not get to 200 milliseconds round trip time between transaction time to the devices, I don't know. But actually it's rather good in terms of adding new boxes, a very huge uniformity, and a very easy way to create the new interfaces. Practically, it can be automated. Going back to the 5G. 5G wants to aim to this vertical markets. Vertical markets is everybody who would need some communication system, starting from railways, health, factory environment, critical infrastructures, and so on. Now, we are here in the middle. The system started developing from the voice system, starting increasing in capacity, adding new services, better coverage, and so on. First of all, increasing to gigabit communication, because more capacity always meant happier users. More capacity is a trend on which you can bet anytime. Second direction is repair the problems from the LTE networks. And the biggest issue of the LTE networks were that very few devices could be connected to the network, and that it took 2 years for people implementing the standards to find out where the SMS is, because they forgot to mention that the new LTE architecture will support SMS. And let's not forget that most of the devices deployed today in a wide area are using SMS for communication. Any type of controllers, weather stations, and so on are based on the SMS. And the third one, which is a bit of a dream still, but may happen, is an ultra-reliable, low-latency type of communication. And this means remote control of cars, remote operation rooms, control of drones, and so on. Of course, being something new, probably it will not happen too fast. 15 megabits per second anywhere in the world, and a sort of flexible network. First thing that happened was, OK, we need to take our 4G networks. This is good for everybody. Phones with multimedia, logistics, agriculture, sensors, everything can go this. Robots can also use their SMS service or their data service. Everything will get connected through the same network. We give them the bit pipe, and that's it. But that was not possible anymore. A single technology, uniform at the size of a country, is not able to cover in a good way all the use cases. So what the operators thought, well, networks become software, let's do everything as slices. We create dedicated networks within our network infrastructure on which we deploy we connect different devices to their own services. And this slicing gave the flexibility to reduce the number of components on the data path, reduce the complexity of control plane, and so on. Practically, it's a dedicated network running a software in parallel into the operator network. And this can be used for virtually anything. Any type of user can take this network, can deploy one of these networks. And think as users, for example, BMW iDrive. BMW deploys its own network on top of a telecom network, and then can transmit content and updates to all the BMW cars. Something like this. Now, the big question here is, why do we need a 5G system instead of a 4G one? And through this one, we are already past. But there is a second approach. And this is coming stronger and stronger in the last month, and soon will become a rather big reality. Why actually depend on the operators? Me, I am at this moment the network administrator for all the factories of BMW. Or I am the network administrator for the railway infrastructure. My company can afford to spend for my network as much as it is necessary, because anyway, compared to the rest of the cost of the production or of the service, this is nothing. And these big companies start asking themselves, why not deploy our own 5G network? We deploy it directly with customized components. We keep the privacy of the data. It is under our own management. We don't need to depend on the operator anymore. I mean, there are some reasons not to do this. One of the reasons not to do this is that in order to reach a country-wide coverage, it will be rather problematic with this type of technologies, especially if the capacity should be bigger in some areas or not. But if it is an enterprise network, I mean, how big should be the coverage of a Volkswagen factory? 1 square kilometer. We put 4 base stations with high capacity. We put another 20 small base stations next to it. And suddenly, there is a small operator network. The question was, why are all these people now running like crazy into this direction? Why is this big pressure now within 3GPP to create this type of private networks? And the answer is mainly on this slide. The 5G system comes with a carrier-grade level security and reliability system. With this one, with guaranteed resources over the network, it's a bit better to connect robots within a factory. Industrial spying, anyway, is one of the greatest business of communication. Still, pushing SIM cards into robots will create a sort of unified authentication. 5G system is finally flexible of access. 5G should work also over Wi-Fi. 5G should work over fixed networks, over optics, over whatever technology is there. So it can integrate with a lot of other technologies. And for wireless, it can go also under 1 gigahertz and have a very wide coverage. It can go to millimeter wave and have very high capacities in small areas. And one of the most important topics is the connectivity on top of unreliable backhauls. Factory A is in city A, factory B is in another city. Deutsche Telekom is not really happy because factory A and factory B have deployed their own mini operator network. So they offer only an internet connectivity between the 2 locations. It has to work over this type of backhauls. The moment that it works over unreliable backhauls, the connectivity and the communication, suddenly the network administrator is really, really happy. And to give you an example of a network which runs over unreliable backhauls today, EduRoam. EduRoam is a university network which runs in most of the university and research institutes around the world with the same authentication and authorization. I have Wi-Fi connectivity almost anywhere. Whenever I'm visiting another university, research institute, hospital in Berlin, some of the train stations where they are doing research, I have the EduRoam connectivity. This is done through a distributed authentication system. Practically, the local authentication server will send the request back to Fokus, and Fokus will send the credentials and so on. This network works. This is a private network the size of the world. Good. Now, of course, operators are offering slices. We give you a dedicated network which is deployed on the Vodafone cloud, which will offer you all the services. Network administrators are looking for these private networks. We will deploy our own private network. The big advantage of slices is actually offloading of all the management of the network towards the operator, offloading of reliability, security issues, and so on to the operators. But this is also the biggest disadvantage of having slices, because if you are a hospital, you need to keep your private network. Bottom line, what is happening today is a full democratization of the networking systems. The moment that these private networks will start spawning up like mushrooms after the rain, the operator network loses the monopoly of communications, even of wide area communications. So today, we have private networks, local networks. These are Wi-Fi. And then we have wide area networks. And even though the phone can jump from the wide area network to the Wi-Fi network and do the offloading to the Wi-Fi networks, they don't have almost anything in common. There are very few deployments that are owned by the operators. Otherwise, almost all Wi-Fi networks are locally managed and locally controlled. Now, what happens with the slicing is that the operators with 5G want to go into these verticals. Enterprise network, factory networks, health networks, whatever networks will be needed. Since less than half a year, also the opposite movement appear. Okay, we don't want operators to actually get into our networks. We as network administrators are more interested in widening our network towards using 5G technologies towards coverage that we will need, so not to depend on the operators. Now, most probably what will happen will be a complete mix. For SIM cards that are business-oriented, the VPN business will remain there. Operators will offer optimized local networks, and at the same time, the private networks will expand to the size. Now, if you're looking from the perspective of a VoIP router, this means that there will not be only one big IMS of the operator. There will be actually hundreds and thousands of owned VoIP structures, VoIP infrastructures. They are appearing. And this already happened once over the best effort IP communication. Now it happens over dedicated type of networks. Okay. I deploy my network very easily. I put my network, I put my base stations, I put everything. I put my network, but I connect it over an unreliable backhaul to some central entity. I put my network, but I'm using the operator in the back to connect this network, or I will put my network on top of the operator network and have an integrated edge-to-edge network. Now, talking about these two use cases, moving intelligence to the edge and integrating the local access networks. First case is very easy. We have only local mobility. I deploy my access points somewhere, the base stations, I deploy the core network, I connect them, I have a small network, it's mine. Second option is I have multiple islands to connect. I will put some kind of a backhaul between the islands. I have connectivity only in my coverage area. And this is EduRoam today. So this is an EduRoam island. This is another one. Between them, there is no EduRoam connectivity. Third option, which may actually happen legal-wise, the forcing of roaming and even national roaming to the large-scale operators. All the Deutsche Telekom devices that join a private network will still have to maintain some kind of reachability for voice and SMS in the macro operator network. This is a typical roaming interface now happening at a national level, let's say. Another option that already happens is we have a second connection. The phone remains connected to LTE, can receive voice calls. We have a second 5G network. Double SIM phones are everywhere. Practically, the phone will have a SIM into the macro operator for macro operator communication and another SIM card for this island or the truck or whomever. And last option is to actually integrate it completely into the operator, give to the operator the right to put base stations, like, for example, the small cells in UK, give the operator the right to do the authentication, authorization, and everything, and ask only for an offloading point to be able to reach with your phone the printer, which is in the same office with you, not to be forced to go to the end of the world and come back. For the only local and for the additional connectivity, the great trick is what are the functions that we are running on the edge side, what are the functions that we are running in central locations, and how do we connect the edges with the central entities. And albeit 5G is a technology that concentrates on new radio communication and new ways of controlling this new radio. What it boils down is connectivity over unreliable backhauls. The rest is just network function placement, and that's it. Now, if it is to roam to a macro operator, again, there will be a backhaul network. There will be peering points that the operator will offer. It will be a complete disaster into the identification of devices. But ultimately, all the interfaces on the control plane will be standard and not so complicated. This might also work. If it is to integrate it into the operator network, I'm sorry for the size of the picture, there are actually three big options. One of the options is that we have a proxy edge node. The macro base station connects a micro base station. The micro base station is actually connecting by itself to the macro base station. So this is a base station that on this side is connecting the device. On the other side is connecting as a user to the bigger base station with local application servers to support the local connectivity. The other option is to have offloading edge nodes where a box comes from the operator, from Orange, for example. It's put into the factory, and it can connect to the local application, while everything related to the authentication authorization is done through the central entity. Or to have a fully extended node that contains also network functions. This depends very much on the trust of the operator towards the network. Okay. Now, this depends very much on how the backhaul will be controlled, what will be the backhaul, and so on. And also depends on the biggest factor. And this is the discussion that's happening today in some of the countries, including Germany: spectrum. The biggest limitation of deploying your own 4G network today is spectrum allocation. And there are several methods. One is, let's use unlicensed spectrum. We put LTE in 5.8 gigahertz, and then it is an unlicensed type of network, and we connect the devices. There are not so many devices available on the market, but this is possible. Second option is a combination of a licensed and unlicensed spectrum. This is what Qualcomm tries to offer at this moment. For reliable part, we use the licensed spectrum and the operator network. For the rest, unlicensed spectrum. And the third option is to have some kind of limited licenses for the coverage of the factory and so on. And here there are a lot of issues in regard to how to define coverage and how to define interference with neighbors, how to reach each corner of the factory while at the same time not go over the network of the neighbor. And if you're living in an apartment building with a lot of apartments, you know what this means for Wi-Fi. So this would be actually the problem. Okay, 2 minutes of infomercial. Okay, so we at Fraunhofer Focus, we are deploying the new 5G playground. 5G playground is actually our way of getting outside of the building into the rain and into the practical deployment. First stage you can see at the Fuseco Forum in November this year. This is an outdoor-indoor combined infrastructure with a lot of levels. Let's find light poles on which to put the base stations. Let's look how to put cables between this and connect to power. Create a sort of management of these nodes in case they get disconnected and so on, to be able to get to them. And then only afterwards to put the packet core, to put some applications on top and show how nice a drone can fly around. So the biggest issues that we met actually were at the lower levels. It seems that not so easy to rent a site to put a base station. Operators were actually very kind to us to give us an allowance for test frequencies. This was not a big issue. What we will have first is, in November, an outdoor deployment with 2 light poles, which will be combined with an indoor operator with different authentication and authorization and so on to test outdoor-indoor type of handovers. Second one that we will have, due to the requirements of the German industry, is a mini factory environment with production belt and robots connected wirelessly and wired, showing the high reliability and communication. Third one that we will have is a truck to offer connectivity to devices around the truck and also to have a mobile connectivity island. And later, towards 2019, we will have a remote driving testbed in the parking lot and a Wi-Fi network in the center of Berlin with authentication and authorization over 5G technologies. What we have today is actually this, an indoor LTE network, wide as 2 floors of Fokus, which we are using to connect different devices, and so on. Good. So this was more or less it. If you are interested in what we are doing, the name of the main toolkit is Open 5G Core. It implements the 5G standards. In September, we will have a first 3GPP compliant release towards the 5G technologies to be ready when somebody comes with a base station to have to offer them something to run in the back. Thank you very much.
Thank you, Marius.